I'm the AWS databases or their computing engine. I mean, it's not free, right? The time you spend, I mean, the application, the test case you apply on your program, you actually have to pay for the storage, you pay for the compute, and you pay for everything, the machine usage, right? So it's not feasible to test them all. We are looking at the execution of this program. We're not looking at source code, right? We're not really funding exactly the source code. We're just saying, okay, from outside, whether it's correct or not. It's not a known environment. Nobody can know the whole environment. And you're not going to be able to apply all the test cases. So you can see that we made a lot of assumptions. So what should we test for? Actually, all these things. So the first thing is definitely correctness. That is what we are asking you to test in your test plan. Okay? I'm not asking you to produce the best performance chat app in the world. No. If your server reply to your client in reasonable amount of time, I think the project manager would be okay. If it takes 20 hours to come back, I think he's not okay, right? So he's basically, he can't sit there for 20 hours to wait for your message to come back, right? But in our case, we are looking at basic correctness. That is, have you considered all the use cases, all the scenarios of each use cases? Have you covered them all? If yes, you have a reasonable plan. Okay? How do we know? Basically, he already gave you the list that you have to cover. Those should be covered by some test cases in your test plan. Right? And we'll look at whether you have considered equivalent classes and boundary condition basically by saying that have you considered corner cases in your scenarios? Right? Things that weird happens. I mean, input not allowed, input allowed, too big, too short, and those kind of things. So is there a way I can give you an input and your system just broken, crashed, totally wrong, right? These are the two things we are looking for in your test plan. Correctness. We're not evaluating you much in terms of utility, which is easy to use. Okay? So if I say I'm going to give you credit only if your chat app is as good as Snapchat, that's an absurd requirement, right? We're not doing that. However, if you are going to go out there and compete for chat in the chat market, you better be better than Snapchat or Instagram and all these things. Otherwise, there's really no point for you to put that app out there. Okay? That is utility. Why people like iPhone, although it's like twice as much. Why we buy an Apple laptop? It's actually literally 3 times the Windows-based the computer. Because you guys believe it's better usage, right? Better utility, easy to use and everything. You trust that is true, okay? So Apple must have spent a lot of time on testing the utility of that system. That is actually a very important criteria. Otherwise, everybody, I mean, according to my own criteria of usage, then everybody should buy a Windows laptop because it's cheap, have all the functionality, even more functionality than an Apple laptop, right? MacBook, why not, right? But which is not true, right? At least half of us actually buy Mac, right? For what reason? Because actually utility is an important factor. You have to test it. The other thing is reliability. I mean, some people may argue that Mac is more reliable than Windows machines, right? I mean, reliability is clearly important in terms of our cars. If your car breaks down every day, I mean, I think you're pretty much going to get rid of your car, right? It breaks down every month. It's already a problem. It breaks down half a year. I think you're not happy. Break down once a year, that's still not too good, right? So essentially, reliability is a very meaningful criteria, especially when you have human life involved, right? Human life involved. We know that's important. Robustness. Robustness means what? We can always get on the internet today. We can always, almost like, so you guys don't, every day how many days in the month have you have trouble to get on the internet? Pretty much no. And so right now we have solved that problem, right? That is the robustness of internet, okay? Robustness of our infrastructure, our software. You actually today, your expectation is when you open your phone, it's connected to the cellular network, you can make a phone call, you can receive messages, you can browse the internet and use apps. Okay? Robustness. No matter what laptop you have, no matter what phone you have, you can connect to the internet and it works. Okay? Internet is super robust. Okay? Then it's come to performance. Why are we buying a new laptop? Why are we buying new phone? Why? A lot of time we are actually motivated by so-called performance. This performance can be many things. Maybe faster, right? Better storage, better display, and all these are criteria of performance. Okay? So these are the things actually you have to test for in your software testing process. On top of what we typically have to do, that is correctness. Correctness basically means, have you covered all the cases of your input and output and your use cases? That's the minimum, okay? That's why in our project we are doing minimum. We are not actually ask you test much about utility. We're not ask you test too much about reliability, robustness, and performance. These things are not critical things in our project. Nice to have, but not critical, right? So if you have, if your system is not the most robust, most high performance, most highly reliable, and most easy to use, we're not going to deduct point from that. I mean, if it doesn't break, we are happy, right? So that is basic correctness we are looking for. Okay, but in reality, you know that all these things actually need to be considered. Your app, if your app is not responsive, performance is low. Take like 5 minutes to load. I mean, that's not an app you want to use a lot of time, right? Robustness, can't get on the internet. Well, that's a laptop you will keep, or you are going to replace it, right? Not reliable, crashes every 5 minutes, right? It's not acceptable, not easy to use, right? So very hard to do anything on it. Like the initial, very early on, Android tablet is in that category, right? So you basically, there's no competition between Android tablet and iPad. But later on, Android tablet really caught up. I mean, so basically, they just use us. As well as iPad today, there's really no difference. Okay? So essentially, all these are critical criteria for us to test. Utility, easy to use, useful functionality, and cost effective, right? That's actually, this is actually user experience, so-called UX, right? Basically, this is UX. Also involve UI. UI and UX is actually a major area of study in our discipline. So basically, how you make your customer happy in terms of using your software product. Important. I mean, in Microsoft, in Google, and Facebook, and Apple, you have an army of UX and UI engineers, basically trying to figure out how to make the user, which are you guys, happy, right? How do you test for them? Well, you just they have their own approaches. We are not going to cover them here. Reliability. I mean, reliability is a matter of frequency and criticality of failure. Right? For instance, our cellular network is 99.99% uptime. Right? So basically, when you push the dial button to make a phone call, I mean, certainly if you are sitting in your basement and trying to dial the network, if it fails frequently, I mean, the carrier probably not going to worry too much about that situation. But if you are, I mean, in your home, I mean, you are in a populated area, you are on the road, I mean, you are in the city, you dial, and I mean, basically their guarantee is 99.99%. Your call will go through. Only 0.01% of time you may got a failure to make a call. Okay, that is a measurement of reliability. Robustness is basically can you keep functioning in all kinds of situations? Okay. So, for instance, if you are you're getting what's the possibility of unacceptable result for valid input? What is the effect of invalid input? Right. So whenever you go to robustness is really so if you give your laptop, you give your program an invalid input, will it fail? Or will it fail gracefully? Right? Either way, maybe okay, but you can't just boom crash, right? So robustness and reliability, they actually mingle together. Right? So your system is robust basically in all kinds of situations. The network is not reliable and all these things. Your program can still function. Performance is actually about time and space. That's the main criteria. In real-time system, you may have time constraints, right? And also your data, if your data allows to be too slow, so that's a possibility, right? So in real-time software system, you actually have to consider time constraints, right? How long? So if you are driving a Tesla, you definitely want to know if I step on the brake pedal, how long it takes for that motor to brake, right? In Tesla, you don't have brakes. Okay. In Tesla, you only have motors. So the way you brake, you basically reverse the motor. Okay. So in Tesla, really, you have no brakes. You don't take Tesla to service for your brake. Essentially, you have the motor, and basically, when you definitely have brake. It's not our traditional car brake. I don't think it's our traditional brake because they actually use that brake system to generate electricity back into the battery. Okay, it has to be. It's actually linked with the motor, which are driving your car at the same time. Essentially, so that's a different situation when you have, in that case, you need to have all kinds of measurements about acceptable performance. Correctness is essentially whether it satisfies the specification, right? So this is come to our definition right now is, have you covered all the cases? All the use cases, and all the scenarios. Okay? If you do, okay, you have basic correctness. Then the other question, which is also important here, is who will check your use cases and the specifications actually match the original English spec? Okay? Somebody else has to do that job. And typically, it's done through review. Okay? Done through review by you or your teammates or your customer. Okay? You can say, oh, I cover all my use cases. By the way, I actually, so they're actually, a lot of functionality in the original English spec, you have not identified as use cases. That is still incorrect, right? So we are checking all your use cases, but in this case, because we already checked your use cases when we look at your requirement doc, okay? You can't say, oh, this is all I have in my requirement document, that's the only thing I'm going to test for. No, your customer are not going to do that. Your customer are going to take their original spec and see if they have anything not identified as use case in the first place. Okay? If they do, then you have to make that up. Correctness specification. So for instance, so this actually can be an interesting thing. Say, okay, what is the definition of sort? Right? So you may say, okay, the input array of integer, output array of an integer such that they are ascending order. This is actually an insufficient definition of sort, because you can actually assign them to the same number, and all zero them out, and you lost all the information of the original array, but you came up with an array which is essentially following the ascending order. Okay? So essentially, this is the insufficiency of your specification. You actually have to say, what you have to say is, not only you have your, the input is an array, the output is also an array of ascending order, and you have to say the elemental array Q is a permutation of elemental array P, which are unchanged. Okay? If you don't have a certain condition, you have incorrect specification. This is the danger of testing only to specification, right? If you have an incorrect specification, even if you have done incredible job to be 100% correct implementation of the specification, because your specification is wrong, you still got the wrong software. Okay? So testing start with your requirement stage. It not just happen after your requirement stage. You need to review your requirement documents. That's why you need that document. You need to review that document to make sure that you got correct specification in the first place. Otherwise, you are going to make a mistake like this. Right? This is actually, if you look at this, if this is your specification, I got an incredibly correct implementation of your specification. However, this is wrong for your customer because you under-specify. This should be caught in the requirement stage, in the requirement review stage, with your customer, with your teammate. I mean, is there a case that this is not caught? Yes. Then you would have to go back, add this to your requirement document, add to this your design, maybe modifying your design, modifying your code, and all the way. Okay? If you're doing agile processes, this is probably not going to cause a major blow because you are actually reviewing the requirement every time. You're deciding what to do next. But if you're a more streamlined waterfall model, this is going to cause a lot of harm. This kind of change will cause a lot of harm. So technically, correctness is not necessary. We are doing fine with all our compilers. We pretty much trust our compilers. But can we say that there are no bugs in our compiler? But we are doing fine. We're creating the internet with our compilers, right? All the code on the internet pretty much are created by compilers, right? But patches, radars are coming up for C++ and other compilers every day. People are finding bugs about GCC almost every day, right? But in that case, even if you have something that's not 100% correct, it still have enough utility for you to do your work. Serve your customer. Is Google 100% bug free? Obviously not. Facebook, I mean, certainly not, right? But do they do their job? They actually do it really well, right? That is, even if you don't have 100% correct software, you deliver enough good utility, okay? You also have a situation when correctness is not sufficient. For instance, the example we give, if you underspecify, even if your code is correct, but your system is wrong, okay? Because you underspecified. There are things that you haven't taken care of in the original specification. That's why, as we mentioned before, you have to start your QA process in your requirement stage, not later. Okay? Right in that stage, reviewing your specification, your use cases, your scenarios, and so forth. Now say, okay, my QA process only happen when we have code. No. I mean, your specification can be wrong, your architecture can be wrong, your design may be wrong, not just your code. I mean, all these things can go wrong, and the best way to give them quality assurance is actually code review, not code review, just review. They're not code. You review the document for specification, for requirement, for your architecture, and for your design. That's the only way. There are no magic bullet here. And for these stages, you pretty much have to eyeball your documents or have multiple people eyeball the documents to give you quality assurance, because they don't run. You cannot apply execution-based testing on those documents. All right, so let's spend about 10 minutes to talk about correctness proof. Okay, so it's an alternative to execution-based testing. You basically say, okay, here's an example that you may see in your exam. Not exactly this piece of code though. So essentially, this piece of code needs to be proven to be correct with respect